minus 2 has an order of
Hello,
1.
advanced function students. Here is another transformations video because you haven't transformed enough yet. So now we're just applying what we already know about transformations to our cubic and quartic functions. So you can notice here I have set up our A value, our K value, D and C value in the exact same places they normally would be with a cubic function. So x to the power 3. So I'm just going to show you that they change a cubic function the exact same way they transform any other parent function. So the A value here is out front of the function. If A is greater than 1, it's a vertically stretching the function. So you'll notice that that makes it kind of thinner because it's stretching it this way, making it taller.
Remind me tomorrow. I want you guys to
if A is between 0 and 1, that's compressing it vertically, which makes it kind of fatter. So think about it being pushed down.
If you get it done, you'll
hopefully
have more time.
And then if it's negative, that means the A value is negative, which means it flips it vertically, flips over the x-axis, which changes the end behavior. And again,
so just remember
a smaller value, so less than -1, we'll stretch it that way, or between 0 and -1, we'll vertically compress it along with the reflection.
Quintic,
so its default then is
what's the end behavior like?
No change. If D is 0, that's actually let's go down to K. So K is again the horizontal stretch or compression. So K is greater than 1. That's a horizontal compression. So think about it being squeezed in. And if K is between 0 and 1, that's a horizontal stretch. So imagine it being stretched out.
So that's what you need to do for all three of them.
If K is negative, then we reflect on the y-axis.
Finally, we get to creating equation. So this is when you're given
there's a really small minus 0.1. You can see it's quite
and you need to actually create
horizontally.
An equation in
and you can continue that this way, and then it's being compressed horizontally.
Is substitute in the zeros.
Its value is 1 if there's no change.
Into the
D, as always, just moves it left to right. Does a little shuffle there. So if there's 0, then it's kind of has its little turning point at 0, 0, and C moves it up and down.
And then you got to decide what the order is. That's what's different.
So there you go. That's basically the summary of the note.
Then you just leave the order
the same thing. Surprise,
if
surprise.
If it's a turning point, it looks quadratic. So it catches it and then goes back down. Or
touches it and then goes so our learning goals are to determine the roles of the parameters. We already kind of just did that.
And that should be a 3.
And then you
keep doing that for however many zeros there
should be a review, but this is using a cubic function where our A value is 8,
where we can put a question mark for the order.
Our K value is a half. Now our D value is not 1.
It's what the order is.
And it's not -1 either. It's actually -2 because we have to factor out K first.
Substitute the
and then -3 is our C value. So our parent function, because of this 3 here,
so that's the other part that people forget is that it's not enough to just put the zeros in.
But we should factor this out before we talk about what the transformations
and find what
so
your
-8 bracket 1/2 bracket x plus 2.
It can then be expanded if it doesn't want it
cubed -3.
So here's an example.
So the transformations performed are
this
negative.
Like it could possibly be a quartic. It could be
on the x-axis.
But anyways, we notice here that we have
a vertical.
Our zeros are
stretch. You should write vertical stretch, but I'm just shortening it here. By a factor of 8.
3. So our function then is
by a factor of 2. Remember, it's 1/2, so that would be 2.
Remember, it's plus 2.
Then a translation left
because it looks quadratic there.
2.
And a this is an order 2.
Translation down.
2. Great. And x minus 3.
So if we make our table of values,
because when
our initial table of
expand this
values
out, you would get x to the power
would be, we'll say -2, -8.
Now we're
this is our parent function
our other known point, which is
of x cubed,
and solve for a. So 4 equals
and then we're going to transform it to our new function.
Bracket 2 minus
so the k values,
so you get 4 equals a.
For the x values,
16.
Are all divided by a half,
so
which means they're being multiplied by 2.
So f at x
plus d,
under my
so minus.
Here, I'll write it over here.
F
2. At x equals.
Our d value is actually -2.
X plus 2
2 times minus 2 is minus 4, minus 4 minus 2 is minus 6.
And you're done. Yay!
Then you would get minus 4.
If you want, you can put in the 0.2 and make sure you get 4 out of it.
Minus 2, 0, and 2.
Okay, here's another example.
And
so we have the path of a dolphin.
Y values.
Okay, write the equation that represents the height of the dolphin
are being
over
multiplied
time.
by -8.
Okay, so hint, the first maximum height of 0.5 meters occurs after 3.5
seconds. So that's minus 64,
so
then another
positive
64 minus 3 is 61.
Okay, so we need, this is a situational problem. So we need to identify variables, don't you forget.
-11
so let
and -67.
Actually, we can use function
So these
notation.
are our coordinates that we can plot.
Height.
So I'm
let
going to have my x-axis increase by 1.
Of the dolphin
4, minus
above
2,
water, okay,
minus
because
4.
we can have negative here.
And my y-axis increased by 10.
So the height above water, that's important that you add that. In meters, you got to have the units at
t, and then I just need to plot these.
Time in seconds. Or sorry,
so minus 6
at time.
Here.
T
plus 61 would be 10, 20, 30, 40,
so
50,
now
60.
you go ahead and do the exact same thing that we did above, just using these coordinates. So I would encourage you to pause the video and try it
5. Smack
yourself.
There. Minus 2,
so
minus 3.
An a value out front that we need to find later. So t minus
2. 0, negative 11.
6, t minus 10.
And 2, negative 67.
Okay, so now we're going to put in the 3.5, 0.5.
So you notice here they're closer together because this is where that curve happens before it goes back down.
Is negative 0.002. It makes sense that it's negative.
Bring it here and make a smooth.
And now you can write your function h at t
here
equals.
Before we start our more rapid descent.
0.002 and then all of that.
There we go. Okay,
right,
you can label the key point
today. Thanks for watching.
Okay, and this is our function f at x. Notice that we can verify that it matches our description. Okay, it's been reflected on the y-axis, sorry, on the x-axis, okay, which is why the end behavior has shifted. Also, it's been vertically stretched and horizontally stretched, okay? So, again, the scale has changed in regards to our original, so that's a bit harder to see. But it has been moved left and down. Now, another way we could have done this was to actually simplify the equation first, which is not as obvious, but I'll show you what I mean. So we have f at x equals -8 bracket a half x, bracket x plus 2, 3 minus 3. So we have this -8, and everything in this bracket is being raised to the power 3. So that means a half is being raised to the power 3, and x plus 2 is being raised to the power 3. So I just expanded this bracket. Well, a half to the power 3 is 1 over 8. So -8 times 1/8 actually just gives us -1. So now we have a much simpler looking cubic, where we could say it's just reflected on the y-axis and then move left 2 and down 3. So you might be thinking, well, that doesn't make any sense. Well, it does, because a vertical stretch by 8 and a horizontal stretch by 2 actually do the exact same thing, whether you believe it or not, when you are dealing with a cubic. So you can try it. You can make the table of values using these A, D, and C values, and you'll see you get the same table of values. All right. So now we're going to determine some roots. Okay, so remember, roots are just x-intercepts, so I just wanted to remind you how to do that. So the word root just means x-intercepts, but it's used a lot more often in higher level math, so just get used to seeing that. So that just means that we need to set y equal to 0 and solve. So remember, if it's in this form, literally all you have to do is set y equal to 0. Sorry, that's 48. And now start moving stuff over and isolating x. Okay, we don't need to factor anything because this is already in this form. So we get x plus 6 to the 4. 48 divided by 3 is 16. So because we're taking the quarter root, we have to take the plus or minus quarter root of 16. Okay, remember this 4 here shows a quarter root. And because this is an even degree, we need to take the plus or minus. Okay, you only do the plus and minus if it is an even degree that you're taking. If it's the power of 3 that you're undoing, you actually don't need to do the even one. And you can think about why that's true, okay? If you don't understand that, please put a star here and ask me about that tomorrow. Okay, so this is x plus 6 then equals 2, because remember it's the quarter root of 16, not the square root. So then that gives you x plus 6 equals 2. Sorry, this should be plus or minus 2. So x plus 6 equals 2, so x equals minus 4. Or x plus 6 equals negative 2, so x equals negative 8. So those are the 2 roots. Okay? This fly is driving me crazy. Okay. Determine the equation of a quartic function that has been stretched vertically by a factor of 2. So that means our a value is 2. Reflected on the y-axis. So that's this way, that's horizontal. So that means k is equal to negative 1. Translated right 3. So our d value is 3 and up 4. So our c value is 4. Okay, so the function then would be f at x equals 2 bracket negative bracket x minus 3 bracket bracket to the power of 4 plus 4. Make sure that you've factored out k to show this properly. So create a table of values. So you just start with your normal quartic. So minus 2 would be 16. Yeah. Minus 1 would be 1. 0 would be 0. 1 would be 1. And 2 would be 16. Okay, so now you just have to put in all your values here. So to get from x to x, you take your x values, you divide them by negative 1 or multiply them by negative 1, and then you're adding 3. And to get your y values, you're multiplying by 2, and you're adding 4. Okay, so go ahead and do that one and check tomorrow with your pod mates to make sure you got the right answer. Okay, here's a practice question for you. Graph this function and label the 5 transformed points. Describe the transformations applied. So this kind of tests a lot of your knowledge, your ability to identify what the A, K, D, and C are, be able to apply it to the table of values, then use that to graph, and then actually use proper vocabulary. Okay, so what I'm also seeing is that you can identify that the parent here is x cubed. Okay, so I'm going to actually leave this for you to practice because that's good for you to do. Okay, just a little hint here. Your a value is negative 1. Your k value is 3/4. Your d value is negative 10. Your c value is negative 5. Go ahead and make sure you know how to do this. Okay, again, I'm going to be checking for this one tomorrow, or that you're figuring this out on your own. And if you're getting stuck, that's definitely a red flag that you need to see me for help before you move on to any of the textbook work. Alrighty. Okay, so here's an example where you're given the graph of a transform function, and I want you to describe the transformations that were applied. Okay, so first of all, you realize that it's cubic. Okay, so normally the vertex of a cubic, okay, it's not the vertex, it's really called the point of inflection. That's where this little thing where it starts going up and then it goes horizontal and it goes up again. It's called the point of inflection. Normally it's at 0, 0, but in this case it's been moved to -4, -1. So therefore we can say that it's been translated left 4 and down 1. Okay, so if we wanted to come up with values, we could say our D value is -4 and our C value is -1. Okay, then what else has happened to it? Well, it's been reflected. So when it is, well, actually, no, it hasn't. I lied. It's going from this way up. It has not been reflected. Has it been stretched? Okay, so from one point to the next, okay, when it's going over 1 x value, in this case, it's going up 3. Now, normally, on a normal cubic, you have 0, 0, right? And then your next, when you go over 1 unit, you're going up 1 unit to 1, 1. So over 1, up 1. Here, when you're going over 1, you're going up 3. So that suggests an A value of 3. So a vertical stretch by 3. Now, you only need to actually recognize a vertical stretch or a horizontal stretch of compression. So that's enough. So here I would say my A value is 3. And I could come up with an equation if I wanted, which would be f at x equals 3 bracket x plus 4 cubed minus 1. So there you go. Fun times. Okay, final question. Determine the x-intercepts of this guy and round to the nearest hundredth. Okay, so this is just like example 2. So how about you guys try this and see what happens. Okay, so you get -2 bracket x minus 3 to the power 4 plus 5 equals 0. -2 bracket x minus 3 to the power 4 equals -5. X minus 3 to the power 4 equals -5 over -2, which is 2.5. Okay, so now you have x minus 3 equals plus or minus quarter root of 2.5. You can finish this in your calculator. Okay, so I actually need to get my calculator out. Of course, it's not clearing. Okay, so I'm doing 2.5 to the power 1/4. That's another way of putting it in your calculator. So you get x minus 3 is equal to plus or minus 1.257433343. So either you get x equals that amount plus 3. So 4.257 approximately, that's rounding. Or that's x1, or x2 is equal to 2.5 quartic times -1 plus 3. 1.743, you'd have to round it up to, approximately. And there you go. So, hope you enjoyed our wonderful foray back into the world of transformations, which never seems to be that far away when you're in advanced functions. And thanks for watching. I hope you learned lots, just as much as that fly did.